Welcome everybody to our SD-WAN webinar. I'd really like to thank everyone for joining us. And today the webinar will be driven by Ronald. Ronald has over 25 years of networking experience and is really focused on SD-WAN adoption in South Africa. And then later on, we'll have a panel discussion, and we'll include Wynand from iTried, who has actually implemented SD-WAN in South Africa and understands it from a practical point of view. And in our panel as well is Justin from Comsol, who's also involved in providing links. Thank you, Ronald. Over to you.
Thanks, Kitesh. I'm going to start the initial slide deck around this webinar, which is basically an introduction into SD-WAN, about what it is not and what it is. So let's go into the brief overview of what Fusion Broadband South Africa is. So Fusion Broadband South Africa is a part of a greater company that is originated in Australia and has gone into the greater Asian market, including Indonesia, Malaysia, Philippines, and Singapore. Fusion has been around for over 10 years, and it's currently in its 8th generation of software. The number of managed service providers include at least 200, with at least 2,000 multi-site PWANs. There's also multiple voice customers, with a customer with over 3,500 sites. And the thing that we're extremely proud of is that in 2020, Fusion Broadband was the IBM Beacon Award winner for Outstanding Infrastructure Services Provider. Okay, basically what SD-WAN is not. So firstly, SD-WAN is not the renaming of firewall VPNs to become SD-WAN. SD-WAN is not about road warrior access. It's mostly about site connectivity, traditionally what a normal wide area network would be. It is not really about remote workers and singular instances. SD-WAN is not about making your Wi-Fi easier to use. It is not, Wi-Fi typically is not involved in the overall equation of SD-WAN except as an additional service. SD-WAN is not the automation of legacy networks. Legacy networks don't automatically become SD-WAN just because they're automated. SD-WAN is a different way of doing wide area networks from upfront. It isn't just taking what you had before and using that. For an example, the legacy ways of doing VPNs is based on IPsec technology, which was around when we were using Novell network servers and IBM token rings from before the turn of the century. So we've moved on for that. So it's a totally new way of looking at things and doing things. It's not a legacy. SD-WAN is not necessarily just a mesh network. Just because you've got a mesh network doesn't mean it's SD-WAN. It's a lot more than that. And SD-WAN is definitely not reactionary security. SD-WAN is a lot more focused on being proactive and not reactionary. So you aren't going to react to an event and then put a mitigation against it. You're going to try and prevent that event from happening from a security point of view. What is SD-WAN? Well, firstly, SD-WAN is about making your internet bulletproof. It is about catering for all types of connections across multiple ISPs and network operators. So in this instance, it would be fiber, fixed wireless, and sometimes even, although it isn't so much the case anymore, technologies like ADSL. LTE might be an option, but it's typically always a last resort, because for a business, you don't want your site to be running exclusively on LTE. You would like something that's more reliable. SD-WAN is definitely about the automation of the last mile provisioning. And what we mean by that is that it is effectively a more automated provisioning. You aren't going to wait days, weeks, or months for a last mile to be provisioned. It's going to be there in a couple of minutes. And the way we do upon that is relying on broadband networks that are available instantaneously, effectively, and as fast as the people can provision it. It isn't like you need a project plan with MPLS to get your links in place across multiple locations. With SD-WAN, secure communications is the default behavior. So SD-WANs are by default secure. Previously, before we got to the stage of implementing SD-WANs, wide area networks weren't inherently secure, and the mechanisms of securing them were an afterthought or bolt-on. Secure communications with SD-WAN is the default behavior. SD-WAN is also about making quality of service with crystal clear voice something that's workable. So you do not have quality of service that is not ingrained as part of SD-WAN. SD-WAN delivers quality of service in a bi-directional manner across broadband links. SD-WAN is all about enabling cloud services, and those cloud services can not only be your office cloud services, of which we've got typical examples of storage solutions or office solutions, or even ERP solutions or CRM. It's also those security services. You can now rely on security services that are cloud-based that protect your organization. The next thing about it is that SD-WAN provides all related auxiliary services that connect you to the internet and make that rock solid. This includes something like name services. Your name services need to be rock solid. You do not necessarily have to have a branch network to use SD-WAN. You can be a single site to use SD-WAN, but many people with branch networks use SD-WAN to implement a branch network. So let's go into if there is a magic source available from Silicon Valley that actually solves all of the SD-WAN problems. And like most things, just because a vendor has got something that's marketed and that is proprietary doesn't necessarily mean it meets the business objectives of what we are looking for. And also, significant innovation has been with products that have been driven by open source efforts, and something like the Linux kernel is a very good example. So the measure of how a solution is delivered is how those services get implemented and utilized. It's not about a box drop anymore. And typically, SD-WAN will never be a good solution if it is packaged as a box drop by a vendor. SD-WAN is one of those services like any other cloud services where it's the overall holistic solution that is important, not just the product and the box. The other thing that we need to remember is that in the latest security problems that we've had, every firewall and vendor out there has had its security compromised either by ransomware intrusion or hacks. So the latest examples have been the Exchange problems and the problems with SolarGate, and even the problems with the VPNs being compromised from all the major vendors across the spectrum. So if a firewall is not SD-WAN, what is it? So at its basic level, a firewall just does NAT and port forwarding, which is an extremely important ability required for you to operate with a private network and your connection to the internet. Most broadband routers nowadays actually do have a firewall. It's not something that is enterprise specifically, and functionally they're the same. The next generation ones added the ability to do signature-based scanning, but typically that's not really that much of an enhancement because mostly people have gone to encrypted traffic, which has negated to a large extent the ability of next generation firewalls to be a box solution. Firewalls have also been vulnerable, especially on the VPNs. During the past year and a half, every VPN from every major firewall has been compromised with some viability. And at this moment in time, the top exploit, as mentioned by the FBI, are those VPNs being exploited in the wild, mostly because the firewalls haven't been updated with code and users haven't actually addressed the problem. So the actual, at this moment in time, that although a fix has been published, it still remains the biggest problem that has been recorded by the authorities. Firewalls are also not the only thing that protects you as far as security is concerned. It is a very necessary cog, but it is not the only cog that a person has. So what are these many cogs that you have in a network? Well, firstly, when you deploy firewalls and you put them in a carpet bombing strategy where you deploy them at every location, each one of those needs to have a babysitter, and it doesn't always work out as the best possible strategy. In the pandemic, one thing we learned is that if a country wants to secure itself, it has to limit its access on its borders, maybe to a single airport entry point or a minimum entry points. If it has got multiple sea or land entry points as well, the probability of people coming into the country during that pandemic and spreading it further is a lot higher. So it is exactly the same when you deploy firewalls. If you've got a central firewall where you choke people and connections to, you've got a lot easier ability to manage the ingress into the network and the security of that network instead of having multiple points across the whole network. As an example, firewalls have allowed the probability of the exchange servers being compromised in the latest security vulnerabilities that have been released. In that context, a network-based firewall didn't actually help. You actually had to go to something more specific called a web application firewall, which actually ran on the host or in front of the host to make it more secure. SD-WAN, in this whole new cog, it changes the way people look at things, and it makes the security a different scenario in that people are secure by default. And it's usually called zero trust networking, where you're evaluated upon a score on the source of that interaction, and it's allowed based upon whether that is going to be a secure communication or not. So the difference now where we had previously is we would upfront determine what our firewall rules would be. Nowadays, we're moving to a place of constant monitoring where we determine what the score is of what we're going to do and whether we are going to allow it. And that's essentially how we get to zero trust networking, where we're only going to go and interact with something that we trust. So the real SD-WAN use case is about why networks fail, and networks will fail regardless about what you do. They are very complex chains, and networks are very difficult, and they're constructed like Lego sets. And I'll explain in detail about what that means. If we look at the fiber last mile, you'll see that there are multiple chains in the actual fiber last mile. The client goes through the infrastructure provider, his equipment on site, the equipment on the curb, the equipment on the backhaul to the data center. There's actually interconnections within the data center. Then there's connections from the data center into the internet. Along that chain, there is a probability of any failure along those points will lead to an outage. A lot of people that I speak to sort of get the impression that there's like, you connect yourself to the internet and it's a singular connection. It can be upwards of a dozen to more than 24 connections before you actually get to the internet, and any one of them can fail at any moment in time. The fixed wireless is very similar. The only difference is that instead of having fiber ONTs and curb boxes, you now have got a client radio and a base station, which runs the last mile over wireless instead of fiber. But you typically have the same number of connections. So how do we actually solve this problem of when you have a failure? Because you're going to have a failure, and you have a failure in a very complex system that's going to happen most likely whenever you utilize the internet. It's not going to be up 100% of the time. You actually need to get two. So we know with jet engines, you'll never climb into an aeroplane that doesn't have two jet engines. We all know that an aeroplane can fly on one jet engine. So if we have a similar situation with SD-WAN, which we have with jet planes of two jet engines, we'll meet the business requirements of having performance, reliability, security, and the management which comes with it. How do we do this two engines on a jet plane in SD-WAN? Well, first of all, we have a SD-WAN CPE that knows that it's got two paths. In this example here, there's a fiber last mile chain and a fixed wireless last mile chain. And that CPE can utilize any one of those. In this example, I've got path A and path B. So when there's a failure on the fiber, it will automatically use the fixed wireless path. And in that manner, we can ensure better uptime. So fixed wireless is a very good example to use with fiber last mile, because, for example, with fiber last mile, if you use this fiber last mile and you've got two fibers coming into your office park, they might also use the same conduit, the same road. And if a trench digger comes in and pulls out the fiber, it might take out both. With fixed wireless, you can at least mitigate that problem of a fiber being cut within the last mile, because typically the fixed wireless last mile typically goes about 4 kilometers away to the nearest base station. SD-WAN has got many attributes. I'm not going to talk about all of them. It's got more than 20 attributes. Are all of them required? No, not necessary. It all depends upon your business requirement, and your business requirement might only require one or two of those attributes. So when you're looking at SD-WAN, you need to say, what are you trying to solve? Are you trying to make it more reliable? Are you trying to make your internet perform faster to the cloud? You've got to know what you want to do. You do not require all of them. You implement those that actually meet the business requirements. What are the use cases for the SD-WAN, and what are these business requirements that you usually have? The one that is very common is MPLS migration. And it's very common from a business point of view, because MPLS is expensive and SD-WAN comparably is less than half the cost on a return on investment over a year period than MPLS. So it's very easy to actually justify SD-WAN from a cost perspective by an MPLS migration. The next thing about it is that if you've got something that is on-prem, for example, if you are providing services on-prem, like on-prem servers or on-prem VPNs, and you want a bulletproof access to it that never goes down, you can do that with SD-WAN. From an ISP, you can actually implement managed last miles for customers. So one of the benefits of SD-WAN is that you get total visibility on what's happening across multiple paths, immaterial of what is happening in the underlying medium. And that allows a person to, when a problem occurs, to resolve it faster, because you know precisely what's happening, because you know that a fiber link has gone down, because you can see the fiber link has gone down from the telemetry that comes over the fixed wireless connection, as an example. You can utilize SD-WAN for rock solid internet access and threat mitigation, where you are actually proactively mitigating security threats. The next very good example, especially in this area of pandemic, where people have made office spaces smaller and relying on other works of medium like work from home, or another example is co-location, which is the hybrid model where people share office space in a co-location environment. SD-WAN is perfect to actually implement in those co-location environments. Cloud acceleration is another example. So instead of having on-prem file servers, you might use Dropbox or OneDrive, and you might, especially in a office environment, you want quicker access to those and not degraded access, which you might do because it's further away, as in on-prem. SD-WAN also solves a lot of problem sites where there are connectivity issues, and it typically solves problems where previous technologies wouldn't just solve it by itself, but SD-WAN is able to run where others can't. Finally, if you're setting up a branch network with a private WAN, this is any type of branch network you can now run across the internet in a secure manner. That is now completing my slide deck about the explanation of SD-WAN. We are now going to go into a brief discussion with Vainan from iTribe and Justin from Comsol, and also Jen from Australia. And then we're going to take questions from the audience. If you can now also, if you've got any questions, just type them in the chat window and we'll look at them and we'll get to answer them.
Well, thank you very much, Ronald, for that presentation and taking everyone through SD-WAN. Every time I listen to the presentation, I learn something more. So we're going to have a brief discussion, and I will start with Wynand. And Wynand, you have practically implemented SD-WAN at customer sites. To start off, give us sort of a short summary of a use case where you've seen the benefits of SD-WAN deliver at one of your potential customers there.
Hi, Kitesh and Ronald. Thank you very much for having us. We're glad to join this webinar. So a brief explanation was already said by Ronald now, where we implemented it at a co-location or a co-working space, which is a typical environment where you have a lot of traffic that you can't really manage. It's a site where you have a lot of different companies with a lot of different needs, and all you need is to have an active internet all the time. So this environment actually, or the SD-WAN helped us with getting that type of resilience and reliability that we required. Another prime example that we're using it at is at one of our schools, or two of our schools now, where the schools need the type of security, and threat management and intelligence, because you never know what the students will browse on their phones or what they will look up, on the devices that you have in front of you. Because all of these type of scenarios are different, schools need to have access to certain websites all the time, and it can never go down. So it's a typical example where we would implement this and they would have the reliability and resilience for this type of thing.
Wynand, just a follow-up question on that. One of the things that's always on our mind is things that user issues that SD-WAN has helped you to solve beyond the connectivity, where, for example, a lot of time would have spent on support and other sort of tracing, where SD-WAN can perhaps reduce the need for troubleshooting and everything else. Have you got examples of anything like that that's come up that has surprised you from what your users do on site, where SD-WAN has helped you?
Definitely. I think, a typical example would be, you wouldn't have access to a specific site. So a site keeps on failing, people can't get to a certain website. Where the SD-WAN helps us a lot is to track and trace that type of scenario. Is it on the client side that the issue is? Is it on the actual server side, on the other end of the telephone, so-called telephone these days? So it's a typical environment where you don't have to go sit with the client anymore. You can literally log in from anywhere in the world and track and trace and make sure that you can try and find out where this issue is.
Fantastic. Bernard, just one question. I mean, you've developed or you've implemented SD-WAN in a number of customers now. Do you see the scalability in terms of how many sites you can manage? Has it helped you there?
Definitely. I think the dashboard that you would get can help you a lot. Because of the implementation into all these sites, it does get a little bit difficult to track all of these issues. With the red, amber, and green scenario on your dashboard, you can immediately see if there's a problem. You can immediately see, if it's a fiber, is it a wireless? By hovering over the amber or the red or the green, it helps you to immediately trace what the issue is, escalate it with your ISP, and within maybe what your SLA is, but within a few hours, you would be able to get to that specific resolution on that link.
Perfect. Bennett, I'd like to bring in Justin now from Console. Justin, you have tested SD-WAN on a wireless connection. What has been the results of the testing?
Once again, guys, thanks for the opportunity. So Ronald and I, probably been playing around with it for a couple of weeks, more Ronald than me. I think he's the techie. But I think really what we've found is, the bonding opportunity of multiple links or one or two links really enhances, performance for customers, number one. So effectively, you take, let's say you take a 30 meg fiber link, you add in a 20 meg console licensed fixed wireless access link, and effectively you're sitting with a bonded 50 megabit per second link. So customers see, a massive enhancement in performance, but very, very importantly, and I think in the SD-WAN world is, by implication, you've got resilience and redundancy built into your environment now as well. You've got two different mediums and two what I call mainstream mediums in South Africa at the moment. And if one does fail, the other one by implication takes over. And if you've got the sizing of your links right, you're either going to see some form of impact on your business or slight degradation. But effectively, if you look at the solutions that Fusion Broadband, bring to the marketplace in terms of size of links and profile of links, then you're probably not even going to see a degradation. In fact, you're not even going to drop a packet. The system is so robust. So we've seen massive benefits to using it, and that all really boils down to the bottom line. If you're servicing people, if you're selling, and for every hour you're down, it costs you money, and sometimes it just takes that very basic calculation to say, do I want two mediums or do I want two quality and appropriate mediums for a couple of extra $100 a month or not? Until you have a failure, and then you realize all of a sudden, my word, saving 15 hours, a month because of one link going down, that could translate to anything between 4,000 and 10,000 Rand a month, depending on, if you're in retail, is it a quiet day? Is it a Tuesday? Or is it a Saturday when there's a lot of people in and out of my store, my branch? So I think the impact is incredible, and I think we generally as a market have to just think slightly further in terms of what is the impact and the cost to my business if I haven't got the right and appropriate infrastructure in play.
Fantastic, Justin. You're speaking my language, so I failed to introduce myself as the numbers guy at Fusion. My name is Kitesh. So I fully understand that. I'll give you another example. In my world, you're just about to make your VAT payment last day of the month and you lose a connection. And if you fail to make that payment, is 10% of whatever you were due to pay on your VAT return. So the business case in that case is made on simply when the failure happens and what does it cost your business. And I think we've demonstrated a number of places where the cost has been significant. So quickly, just adding in John from our Australia office. Welcome, John. We want to ask you, can you share with us a use case of SD-WAN in Australia?
Yeah, oh, sure. There's so many. It really is genuinely hard to choose because SD-WAN really opens up such a vast array of opportunities compared to a traditional inflexible network. If I was to give you a few examples, so in Australia, we haven't had fast sort of broadband for very long, which is surprising. So where SD-WAN fit a bit of a niche market many years ago was to increase speed. So we were all running on ADSL. Very few people had fiber. It was just ADSL. So at that period of time, Fusion Broadband was able to come in and bond multiple ADSL connections together and make it appear as one pipe in and out, same static IP address, and these customers would just have a much better experience because they had more bandwidth. And over time, that has changed. So now speed isn't the main driving factor. It's still there, but it's not the main factor for us. At the moment, it's got to do with failover. So what has happened over here is the government has had this massive rollout across the country, and they've upgraded the broadband circuits to basically every household in general. But what this has meant for the business customers is that all of their credit card transactions, all of their phones, they were forced to go onto voice over IP, whether they wanted to or not. The existing copper network is gone, in essence. So credit card goes over the internet. voice over IP goes over the internet. And then all of the MSPs, the IT providers, came in and thought, well, this is great. We can finally upgrade our clients, get rid of the servers and bring them into the cloud, Microsoft, Amazon, wherever that may be. So now the risk is so much higher because if their internet goes down, their business stops. In the past, their internet would stop, but they could still take phone calls, still take payments. That's not the case over here anymore. So there was a big shift from bandwidth aggregation into now failover. And this is even from the small business level where you would have one primary internet circuit of any type, but you would also have a backup circuit, as Ron was saying, like a fixed wireless or an LTE circuit or whatever that alternate would be, so that if your primary link goes down, your business is still trading. And what really brings this together is the fact that it's the same static IP address. So no matter what is up or down, your IP stays the same, your sessions stay the same, and most importantly, there is no outage. So if you are doing a consistent ping, in most cases, you won't even see not one dropped ping packet upon a failure. So that's been a big shift. And moving on from there, of course, you then get into more of the multi-site opportunities. There are so many cloud vendors to pick now, Microsoft, Amazon. Do you want to put all of your eggs in one basket, or might Microsoft have a better offering to host a voice service, or AWS has cheaper servers? Whatever it might be, you can actually now combine all of those cloud providers into one private network. Ultimately, our customers are finding over here that they're loving the flexibility of being able to build their own network. Every site and every location can be built with the bandwidth that is required, with the combination of different ISPs at each location independently. And back when we were talking about MPLS, if your MPLS provider, if you had a location in an area that they didn't service or it was too far away, that would mean an awful lot of money. And now you can pick and choose ISP over here, a different ISP over there, and you can pull in all those different cloud resources.
Thanks, John. You've given us quite a big summary, and it's almost given us a window into the way South Africa is potentially moving. I mean, we're moving in that direction. We're a little bit behind, but cloud services are definitely taking off, and we see similar trends in the SA market, which we can take advantage of. So just in final question, I'm going to ask Justin. Justin, in terms, you see the growth opportunity here in terms of the SME market, as well as most South African businesses up to now have had a strategy that involved the physical space, and with COVID and all the changes, people are moving online, but most of them still have just one link and have reliant on one link. Justin, do you see the growth point here of people wanting more than one link going forward?
I think definitely. I think the benefits that the Fusion Broadband solution brings to the marketplace absolutely speaks to that. And as I said earlier on, for a couple of $100 a month, having the right infrastructure and the robust infrastructure around building your own brand and your customers' experience is incredible. And I think it's an understanding of the different connectivity types. And even though I beat the fixed wireless access and licensed wireless services that Comsol provide in the marketplace, there is still place for all the other connectivity solutions. And I think a lot of the SMEs and a lot of the customers need to weigh up the cost of what infrastructure they need, and I think we as players as well, even though it might be referred to as the plumbing or a utility service at a point in time. If you look at the emphasis on the internet and connectivity and remote working from home, it's even more important in today's world, now that there's this this hybrid work from home model. And we unequivocally see a great opportunity for growth in the marketplace, and not only growth for like replacement services, but a much better quality service linked to a fiber service to provide customers the services, the reliability and peace of mind that they need in the marketplace.
Thanks, Justin. And in closing the panel discussion, I'm going to talk to Wynand quickly. Wynand, in terms of the opportunity you see in the SME market, a final word from you, Wynand, from iTried. Obviously, you're a managed service provider, so you're seeing it from the customer side, solving problem side. the opportunities going forward?
Yeah, so there is definitely opportunities, and I think, as Justin say, you know, you can implement a console link, you know, quickly on a site, you know, and get the same reliability and features, you know, over the wireless managed wireless link, you know, and while you're still waiting for your fiber to be installed. It's a typical example of what we are doing. You know, we have a short turnaround time, you know, installing networks, and it sometimes takes months to install a fiber link. You know, you can easily quickly set up a SD-WAN with a console link and get the robustness and reliability of the SD-WAN and the features while you are waiting for your typical fiber link. But you know, coupling these two together is definitely a thing where people are, you know, they need the robustness, they need the reliability of fiber and wireless.
Thank you, guys. Thanks, Venat, for that last words, and thank you for sharing your valuable knowledge with regards to the opportunities, SD-WAN, problems that it solves, and all of that. So, Ronald, we're going to take some questions that have come from the participants, and any particular question you were going to start off with.
So yes, so some of the questions are very technical, some of them are less technical. So I'll start off with I'll mix the questions up and go from a technical to a non-technical question. So firstly, we've got a question about what is our opinion regarding meshing within an SD-WAN environment. So the architecture that you can use in SD-WAN consists of two types. One is a mesh and one's a hub and spoke. So what that means is in a mesh environment, everybody speaks to everybody. In a hub and spoke, a person that's at a site can only speak to a hub. So there are benefits of hub and spoke, and there would be benefits of a mesh. So a mesh is typically how the internet is constructed, where you've got multiple cities talking to each other. In that environment, you aren't always optimizing the last mile path. So here in SD-WAN, we're talking about the last mile and optimizing the last mile path and making certain that we can fail over on it. So the way we approach it as Fusion Broadband is we use a hub and spoke mechanism to the nearest data center. And from that data center, we allow multiple paths coming back to the edge, which allows you to fail over. And also it allows you to fail over extremely quickly, because that's what we want. We want reliability. In a mesh environment, you do not know what the status is of both sides of the link. So in a mesh environment, you typically take upwards of 30 seconds to fail over between links. Now in 30 seconds, you'll lose your connection, you'll lose your transaction. You might have to start again. And if your transaction has been corrupted, it might take you quite a while to actually recover and get back to where you were. So in the last mile, it's a lot better to use a hub and spoke. However, when you have a large branch network, and let's take an example, you've got branches in Cape Town, Durban, and Johannesburg, and you want them to speak to each other. It doesn't make sense to have a single hub for the whole country. It makes sense to have a hub in Durban, a hub in Cape Town, and a hub in Johannesburg. Now you've got 3 hubs. The best mechanisms to let those hubs speak to each other is with a mesh network. So when you're building the hubs and getting the hubs to speak to each other, you mesh them. What that means is Durban can speak to Cape Town and Johannesburg. Johannesburg can speak to Cape Town and Durban. And so they all mesh to each other. And as you add more and more sites, for example, if you add London, you'd probably add London in a mesh on the hubs. But you wouldn't have a hub and spoke mechanism for all countries and all connections. The next question we have is around the different use of multiple links with different form factors, and how does a SD-WAN cater for something that is asymmetrical in a broadband environment? So for example, broadband, most links that you buy for fiber to the home or fiber to the business is asymmetrical. You'll have 100 megabits per second down and 50 megabits per second up. So what you would do typically often in a normal environment, even if you had a router and two routers, you'd only be able to use one connection path. So your uplink would be 50 megabits per second in the example where I said you had 100 down and 50 up. If you had multiple lines and you had 200s down and 250s up, you would get 200 down and 100 up. So immediately the bandwidth that you're utilizing is aggregated across the number of links that you have. So you'd still have asymmetric bandwidth, but you'd have the ability to use all of your bandwidth going up and down. So in this scenario, you wouldn't just be able to do 50 up, you'd be able to do 100 up. The next thing is, how does packet loss affect the SD-WAN solution? Well, in many of the cases that we've gone, we've actually found that SD-WAN is in a way able to mitigate packet loss problems. Now, packet loss problems aren't just restricted to ADSL wireless. They also happen often on fiber. And what you notice when you have packet loss on a fiber is the immediate thing that gets a connectivity problem is international sites. International sites start slowing down. So in Fusion, we've got the ability to mitigate those packet loss scenarios and still maintain connection to international sites at full line speed. And that we do by actually mitigating the actual problems associated with packet loss. So one of the immediate problems that you have with packet loss is when you use something like TCP, things become out of order. You have to have a large number of retries. So we're able to, with our technology, minimize the number of retries that are required and the number of packets that arrive out of order. And minimizing that, there is a mechanism of being able to mitigate the actual problem with packet loss. Another mechanism that a lot of SD-WAN utilizes is something called forward error correction. The only detrimental aspect of forward error correction, which also does mitigate packet loss, is that you require more bandwidth. So for example, if you had problematic sites, you would be utilizing more bandwidth, not less bandwidth. Sometimes it might mitigate the problems. Often you might exacerbate the problem because you're putting more bandwidth to a solution that doesn't necessarily solve itself always with more bandwidth.
So Ronald, if I can ask the one question that's in my mind is how does SD-WAN, if you've bought a particular link at a particular bandwidth, how does it accelerate to the cloud? Because obviously it says you've bought a certain capacity. Acceleration to the cloud, is it linked to
firstly, the obvious one is the aggregated bandwidth. So for example, if you've got 20 megabits per second fiber and 20 megabits per second wireless, you can use now 40, and that's immediate benefit. The other method that a person utilizes is there's a mechanism of very well known called TCP acceleration. For example, have you ever heard of people complain about their YouTube quality?
No.
The reason for that is because Google has rewritten YouTube to use a specific algorithm called BBR, which is an algorithm that when packet loss occurs, it doesn't actually pay attention to the packet loss that has occurred, because with video that has been transmitted to a person, you want it to be there as consistently available as possible and not to stop and, what typically would be called buffering. So YouTube has got that nailed down because it's got this algorithm called BBR, which allows you to actually do that and mitigate that. So those types of mechanisms are available in SD-WAN. There are probably right now about 14 congestion control algorithms available. And depending upon the situation, one congestion control algorithm will work better than others. Then the final way of actually improving cloud acceleration is to actually have multiple TCP sessions, not just one. For example, if you have a storage solution like Dropbox and you synchronize your laptop to it and it takes 50 minutes, if you connect multiple TCP streams to that instead of one, and you, for example, do 8 to 12, you can immediately improve the speed on which you synchronize your hard drive to comparably 8 times. And I've typically done that often on my laptop, and it's quite impressive that the synchronization gets speeded up so fast.
Thanks.
Okay, the next question we have is about the actual centralized internet breakout. So SD-WAN, you can have centralized breakout or you can have localized breakout. And in essence, you're talking about what is the benefit of centralized breakout versus non-centralized breakout. Well, in South Africa, it is actually a moot point, because in South Africa, all our internet goes through very limited data centers. Even if we do an internet breakout in our office where we are here right now, we would follow the exact same path physically that we would if we did a centralized breakout. So in South Africa, given the physical constraints and the limited number of data centers we have, there is actually no difference between centralized and decentralized internet breakout. It's effectively the same. It's effectively the same thing. So why would you actually want to do centralized breakout instead of decentralized breakout? Well, if you're an organization with 60 branches and you do 60 localized breakout points, you just got 60 points more to manage. Yes, you can say your automated software is going to make that better, but you still got the probability now of having that internet breakout as a probability where you have to deal with 60 breakout points where you can have one. It comes down to the thing with, would you rather look after one entry and exit point than 60? It's going to be a lot simpler and more reliable to look after minimized entry points in and out of the network.
But that also has a security benefit.
Correct.
Because then you're essentially managing one access point, one gateway into the rest of the network.
Correct. I mean, it reduces the probability of you having a backdoor into your organization, which you don't necessarily want. The other thing about it is that when you are doing things like having firewall functionality in a decentralized manner, in a small office, you're not going to get a high-powered firewall. You're actually going to get a low-powered firewall. You're going to get something that's cheaper because you're not going to buy something that's expensive for that office. So you're going to get a cheaper firewall. A cheaper firewall means less functionality, less performance, less ability to provide reliable security. If you have a centralized breakout where you take all of your offices and you consolidate it into a data center, that allows you the ability to actually buy a high-end firewall and spend more money on it. Spending more money on a high-end firewall will ensure that the hardware is better. It can take performance better. It can take security breaches better. It can take denial of service attacks better and mitigate them in a better fashion. It can execute the rule-based better. So you get all of the benefits of you getting a better device and being able to afford a better device by aggregating all of your costs and putting them into a singular cost instead of spreading them out all over the place and reducing the quality of what you get at a single site because you have to cover multiple sites with a cheaper bit of hardware. Okay, the next question that we have is around how many forms of connectivity can the SD-WAN handle at a site? So in South Africa, we have got a maximum of 3 types of connectivity at a site. But over in Australia, there is a site that can handle up to 12 different types of connectivity. In reality, you're constrained not by the SD-WAN itself, but by the ability to actually get physical connectivity and different types of connectivity into a site. For example, we struggled in our office park to get more than one fiber connection. The office park has only had one fiber trenched into it, so we're totally reliant upon that. We can get multiple wirelesses, but after that, we're not going to get anything more. So in SD-WAN will handle as many types of connections that you throw at it. The problem is going to be, is at that location, are you going to be able to get that many types of connection to that particular site?
So just with that point, Ronald, we've tested on using satellite, for example, in the very beginning.
Yes.
So that's another form of connectivity in terms of areas that are not covered by either technology. And in order to get greater bandwidth, for example, out of satellite, if you fused 2 or 3 satellite connections together, you would then get greater bandwidth in, for example, a rural area.
Correct. So, and at this moment in time, satellite is still an expensive option, but it is a very reliable option. The uptime on satellite is very good. But typically, satellite connections have larger latency and they're slower. There is definitely more of those connections that are going to come in once Starlink becomes widely available and they've sorted out their deployment issues and it becomes available, because there it's going to be reasonably good bandwidth of at least 20 megabits per second with better latency. So you would be able to actually utilize that in a remote location when there is nothing else available, or as a means of backing something that you've already got.
Yeah, so the Sd-Wan is ready for that development.
Correct. So next question here is, how important is it to consider the underlying design when building an Sd-Wan solution? So it all depends upon the market segment that a person is playing in. For an example, in an enterprise market, when you're working with a big bank or a big retail organization, it's extremely important to look at the underlying design because of the complexities in their IT system. They've got extremely complex IT systems, and you're going to have to design and look at the design specifically for an enterprise. And typically, as soon as you start doing that, there's costs involved, and the Sd-Wan solution for that enterprise is typically going to be proportionately larger. In the small business environment, you've got a lot more consistent in the way that businesses handle their communication requirements. One small business's communication requirement isn't going to be that much different in the small business environment than another business. In the enterprise market, you'll never find 2 enterprises with the same communications and requirements. So there it becomes less of an issue in the small business environment. There, what you want is something to deliver consistently and as fast as possible. In an enterprise market, you're typically not going to be able to deliver something unless the enterprise changes its behavior and way of doing business, that it is actually a cookie cutter business, that it actually does things in a rapid manner, in a consistent manner. Then it will probably fit well into the enterprise market, and the actual design of an enterprise solution that's specific to the enterprise will become less important. But at this moment in time, enterprises are very customized in how they've done things, and they will probably remain like that for a while. The benefit of the cloud solution is that when you get to the cloud, you're forced to do things in a standardized manner, and you're forced to provision and do things in a more structured manner. So as enterprises move more and more to the cloud, the ability to force a standardized mechanism that is easier to deploy for enterprises will become more probable and more likely that they'll be able to do that.
Yeah, but Ronald, one of the things that exists in South Africa still is a lot of companies still have servers on premises.
Correct.
A big percentage of small, I mean, we're talking enterprises, fairly large companies have servers on-prem. And that's one of the things we didn't really spot, where customers were requesting a failover and reliability and multiple links into the business rather than going out of the business, essentially to provide reliability of all those remote workers remoting into servers that are on premises.
Yes, for example, the on-prem business has been largely underestimated because a lot of people said the natural migration is to go into the cloud. But the cloud doesn't necessarily always fit everybody's pocket, because if they've spent something on-prem, going to cloud is an additional expense, no matter how you look at it. The other aspect of a cloud migration is that there are typically project costs associated to it. and the costs of cloud are on demand. If your business is consistently the same and doesn't change day by day, eventually, when you do the maths, it's going to pay you to keep on-prem and do things with your own hardware than it is to use cloud hardware where the costs are larger. However, if your business is such that it fluctuates greatly from day to day, from month to month, from season to season, there's no way that you can keep on that type of scale with on-prem solutions where suddenly you need to go and buy 100 new servers. You can never do that. Then there you're forced to go to cloud. Okay. So there is the thing, and a lot of businesses have on-prem servers and they actually don't need to move yet.
Okay.
The next question we have is, in your opinion, why does SD-WAN make applications perform better, faster, excluding acceleration if built into the solution? So the mechanisms that SD-WAN utilizes is when you have a system that is able to do failure within a couple of milliseconds as opposed to 30 seconds, it makes it more reliable because you don't have to restart your transaction. The other question is when you have acceleration built into it, and that's one of the benefits of SD-WAN, is you can often purchase solutions that do accelerate your traffic type as an additional service that can be integrated into SD-WAN. But that is very specific to the type of application you're using and the business requirements for it. So it's not a generic thing that all applications can be accelerated, but definitely there are those that can be accelerated, and there are those that can be accelerated with third-party solution add-ons that can be integrated into SD-WAN. What additional security features does Fusion Broadband have in addition to firewall capability, something like DNS? So at Fusion Broadband, we've actually developed a rock-solid DNS. And the way we do our DNS is we utilize multiple upstream DNS providers. One of the big things that is overlooked and how people don't understand around DNS is there are DNS services that provide you a great security benefit by utilizing them. An example is Quad9, which is actually sponsored by IBM. What Quad9 does as a DNS is if you're using Quad9 and as a business you're using it, it immediately blocks your laptop or anything on that site from getting to a command and control server where people can actually put malware and control malware on your laptop. It blocks all of that access immediately. So it immediately makes your network secure just by doing that. The second thing that you can actually do, which is the proactive blocking of websites. So for example, somewhere in the world right now, there is somebody who is trying to hack somebody. The addresses that those are coming from are known within a couple of minutes. So there are organizations like IBM and other organizations that do publish that knowledge to you, which is called threat intelligence. You can take that threat intelligence and apply it immediately to your site and say, we know that there is, for example, a server hosted in a cloud location in Los Angeles, America, that is a command and control center for malware. Just block access to it. And immediately anybody from your site who is going to go there is going to be blocked, and it's going to stop that type of malware from spreading. We are actually, we've got a couple of other questions, but we would, we've got one or two questions still that has come from the audience, but what we will do is we'll answer those directly and send them to the guys who've answered the questions.
Yeah. Well, thank you for all those questions. Hopefully this has been an informative session. We've got a lot more questions, and I think what we're going to do is, Ron, we will answer them, definitely. And anybody else who's got questions, we can be reached. Send us an email on sales@fusionbroadband.co.za. That email again, sales@fusionbroadband.co.za. And we'll gladly answer any question and queries, and especially if you want any more information. I think we want to share the knowledge and try. And Ronald's goal is to promote SD-WAN adoption in South Africa. Well, thank you for joining us.
Thanks, everybody.
Thanks to our panel. Thanks to our panel members.
Thanks. Bye-bye.
Cheers.